Hello everyone. First of all, thank you for being here and thank you for your great response for our both the crash courses for both CAT, TISNET, CMAT. So many of you are making use of these courses. So this is a session of quadratic equations. So we are continuing algebra. In the first session, we have learnt about the linear equations. In case you haven't watched the linear equations lecture, kindly watch that and come back to this session. So this is a complete session of quadratic equations where our agenda is first we will look into the quadratic equation and the quadratic expression, the difference between these two. Then we will move on to the graphical representation and we'll learn how to find the roots of quadratic equation and how to form a quadratic equation, solving the inequalities, quadratic inequalities, sum product of roots, the discriminant and the nature of roots, maxima and minima. Of course, maxima and minima is not very important for TISNET, for SNAP, for CMAT. However, this is a critical topic for CAT and XAT. And then we'll move on to condition for one common root and two common roots, and then the relation between coefficients and roots, and then we'll move on to the Descartes rule of signs. So besides learning these concepts, entire concepts, we will also solve different questions, right? We will pick up each and every question. We will cover maximum models, and in our advanced sessions we will solve much more questions of the higher difficulty level, right? So what is the difference between quadratic equation and quadratic expression, right? Or quadratic function, let's say. So if we say the quadratic function, right, the function or expression can be given by f of x, which will be equal to ax square plus bx plus c, right, where a, b and c are constants, and a shouldn't be equal to 0. Why a shouldn't be equal to 0? Because if a is 0, then this entire thing will be 0, and this is no more a quadratic equation. This will become a linear equation, right? Linear expression, right? And coming to quadratic equation, if we equate this expression, which is ax square plus bx plus c, with 0, right, this will become a quadratic equation, not expression. But what is the real difference? Here we are not equating this with 0, here we are equating this with 0. And one more thing is, we do not have roots in quadratic expression, right? We have roots only for quadratic equation. And if you observe one more thing, in quadratic expression, if we keep on substituting the values of x, then we will get the corresponding values of f of x, right? Whereas in quadratic equation, we have only two roots. We can maximum have two roots. We won't have more than two roots in a quadratic equation, right? So we have roots only for quadratic equation and not for quadratic expression. And we can also equate this f of x with y, and we can say that y is equal to x square plus bx plus c as well. So now we are using this graphing calculator, which is available at mathsisfun.com. So if we consider any quadratic function, right, the graph of that will be a parabola. If the coefficient of the expression is positive, it will be a U-shaped parabola, or if it is negative, it will be inverted. Let us see how. If we equate y with x square minus 1, let us equate now. So x square minus 1. So this is the graph for x square minus 1. If you observe, the coefficient of x is 1, which is positive. So you can see this yellow color parabola. If you closely observe, this parabola is cutting the x-axis at -1 and 1. What does this mean? Whenever a quadratic expression is cutting x-axis at 2 points, we can confidently say that those 2 points are the roots of the quadratic expression. What do you mean by roots? Roots are nothing but if you substitute any one root, right? Let's say if you substitute 1 in the place of x, that will satisfy the equation. If you can substitute any root, it will satisfy the equation. What happens if we substitute a negative coefficient in this expression? Let's see. Now I am taking negative value of x, right? Let's say -5. Now where is the graph? The parabola is, see this yellow colored parabola, it is inverted. It's in the reverse direction. So whenever the coefficient of x square is negative, the parabola will be inverted, and whenever it is positive, the parabola will be U-shaped upwards. And if you observe, whenever it is inverted, we will have the maxima, right? So this -1, this is the maxima, and whenever it is upwards, we will have minima. We will discuss this in the upcoming slides as well. So your observation must be, whenever it is positive, the coefficient of x square is positive, the parabola will be in this direction, and when it is negative, it will be inverted. And what happens if the coefficient of x increases? If it is 7, it shrinks. If it is 15, shrinks even further. 45 shrinks a lot. So whenever the coefficient of x square is increasing, the parabola shrinks, and whenever it is decreasing, let's say if we consider -45, it is towards the other side, right? So this is an observation that you all have to make. So what did we learn from the graph? We learned that the graph of a quadratic expression which has a positive coefficient of x will be U-shaped, and if the coefficient of x is negative, it will be inverted like this, right? Inverted parabola. And if the parabola touches the x-axis, if it touches the x-axis, then the two meeting points are the two roots of the quadratic equation. Now, how can you find the roots of the quadratic equation? Let us look how. To find the roots of the quadratic equation, we have two methods. The first one is splitting the middle term, and the second method is the quadratic formula method. We shall see one by one. First, let us take a quadratic equation. X squared plus 5x plus 6 is equal to 0. Now, in the first method, which is splitting the middle term, let's say the two roots of the quadratic equation as alpha and beta, right? Let's name them as alpha and beta. We must split these two in such a way that alpha plus beta must be equal to 5, which is the coefficient of x, and alpha beta, the product of these two roots, must be the constant, which is 6 in this case, right? So by trial and error method, we can say that roots of this equation is 2 and 3, because 2 plus 3 will give us 5, 2 into 3 will give us 6, right? So x square plus 5x can be written as 2x plus 3x, and this is 6. So x plus 2 into x plus 3 is equal to 0, and x can be -2, x can also be -3. If we take this, it will be -2. If we take the second one, it will be -3. So these two are the roots of this equation. Now let us apply quadratic formula method, see, you can follow any method. Sometimes this will be comfortable, but sometimes this is comfortable. In case the equation is somewhat complex, then it's better to use the quadratic formula method. Let's take one more example where x square plus 6x plus 10 is equal to 0. This is one more quadratic equation. Now, in quadratic formula method, what is the formula? The formula is given by roots is equal to, so the formula is given by minus b plus or minus root of b square minus 4ac by 2a. Here a is the coefficient of x square, c is the constant, and b is the coefficient of x. So we can substitute this minus b, which is minus of plus 6, which is minus 6, plus or minus root of b square. 6 square is 36 minus 4 into a into c. A into c, 10 into 1, which is 10. So 4 into 10 by 2a, which is 2 into 1, which is 2. Now this is equal to minus 6 plus or minus root of minus 4 by 2. If we consider plus, we will get one value. If we consider minus, we will get one more value. So those two roots, those two values are the roots of the quadratic equation. So in this way we can apply quadratic formula. Now how can we form a quadratic equation? We have three cases here. The first one is when roots are given, right? The second case is when sum of the roots and the product of the roots are also given. In that case we must find the quadratic equation. And the third case is when the roots are related to the roots of another quadratic equation. We will look into one by one. See, here two roots are given, right? When roots are given, form a quadratic equation whose roots are 1 and 2. So we shall name them as alpha and beta. And we know the general equation of a quadratic equation, right? Which is x minus alpha into x minus beta. This will be equal to 0. Just substitute here x minus 1 into x minus 2 will be equal to 0. If we expand this, we will get x square minus 2x minus x plus 2. This will be equal to 0, and this will be x square minus 3x plus 2 will be equal to 0. Now this 3x is the sum of the roots and this 2 is the product of the roots. How can you say it is sum of the roots and this one is product of the roots? See, the roots are already given 1 and 2. If we add this, 2 plus 1 will be 3. 2 into 1 is 2. So if we add the roots, this will become the sum. If we multiply, this is the product, this is the constant of this quadratic equation. So in this frame a quadratic equation when the roots are given. The second case is when sum of the roots and the product of the roots are also given, right? For instance, form a quadratic equation such that the sum of the roots is 4 and the product of the roots is 3. So in this case, what is given? Sum is given, alpha plus beta is given, which is 4, alpha beta is 3. I think we haven't generalized this equation. Okay, see here x square minus 3x plus 2, which means x square minus sum, s means sum, s x plus here 2 is the product, so p is equal to 0. We have generalized this equation. So next time when you have the roots, just substitute in the place of s and p, just take the sum and substitute here and the product and substitute here. Here that is what we have. Here x square minus sx plus p is equal to 0. We have sum, that is 4. We have product, which is 3. We can directly substitute in this equation. X square minus 4x plus 3 is equal to 0. This is the quadratic equation when the sum of the roots is 4 and the product of roots is 3. Now what is case 3? Case 3 is when the roots are related to the roots of another quadratic equation, which means we will solve this, you will understand better. So form a quadratic equation whose roots are 2 more than the roots of the quadratic equation which is given. So here if you observe, the roots of this equation is 2 more than the roots of another quadratic equation. So it is dependent, right? So it is related to another quadratic equation. So x square minus 3x plus 2 is equal to 0. This is the equation given. Here what is the sum of the roots? Alpha plus beta, this is 3. Product of the roots, this is 2. Now the question is, the quadratic equation which we must form is the roots of that quadratic equation are 2 more than the roots of this one, right? So that one will be alpha is equal to alpha plus 2 and beta in that case is beta plus 2 because 2 more. See, we considered alpha and beta as the roots of the equation that we will form now. So for that those roots are 2 more than the roots of the equation, this equation. So we are just adding 2 for one root which is alpha and for another root as well which is beta. Now what is the sum of the roots? Sum is alpha plus 2 and beta plus 2. Alpha plus 2 plus beta plus 2, this is the sum of the roots, and we know alpha plus beta as 3, right? So alpha plus beta plus 4 and this will be equal to alpha plus beta is 3, so 3 plus 4 this will be equal to 7. What about the product of roots? Product is alpha plus 2 into beta plus 2. If we expand this, we'll get alpha beta plus 2 into alpha plus beta plus 4, right? Now alpha plus beta we know which is 3 and alpha beta we know that is 2. So 2 plus 2 into 3 plus 4, this will be equal to 12. So sum of the roots is 7, product of the roots is 12. Now we can directly substitute in the generalized equation in this equation. So x square minus sum of the roots is 7x plus the product of roots which is 12 is equal to 0. This is the equation, quadratic equation that you can form when the roots are related to each other, right? So this is a table where for the change in roots, the change in quadratic equation occurred. See, for instance, if alpha and beta are roots of a quadratic equation and alpha is increased and beta is also increased by p, then what will be the change in quadratic equation? It will be alpha into x minus p. If it is plus p here, it will be minus p, and it is plus p in the second root, it will be minus p in the other in the quadratic equation as well. If it is alpha into p, then it will be x by p, and if it is alpha minus p, it will be x plus p, right? And there are other cases as well, like a root becoming square, right? Alpha is becoming alpha square, beta is becoming beta square. Then what will be the change in quadratic equation? Alpha to the power of n something and beta is also to the power of n, then what will be the equation? So you shouldn't remember all these things, right? For what value of changing the roots, what will be the change in quadratic equation? So you shouldn't remember all this. One thing remember, whatever is the change, just equate that with x. For instance, let's say alpha and beta are increased, or alpha is changed from alpha to alpha into p, right? Then what you must do is equate alpha p with x. If you equate alpha p with x, what do you get? Alpha as x by p. This is what you have substituted here. For instance, take alpha minus p. Alpha minus p, just equate it with x, then alpha will become x plus p. This is what you substituted here. So whatever is the change, just equate that with x and find out the value of alpha. Just substitute that in the places and you'll get the modified quadratic equation. Now moving on to quadratic inequalities. Let me give you one inequality which is 2x square plus x minus 15 greater than or equal to 0. Now how can we solve this? How can you find the solution set of this inequality? Let us see how. The first step is same, just find out the roots of this quadratic inequality. You can use any of the two methods which we discussed in the previous slides. So let us split this equation let us split this inequality. 2x square plus 6x minus 5x, this will be equal to 15, and this will be greater than or equal to 0. Minus 15 is greater than or equal to 0, and 2x into x plus 3 minus 5 into this will be x plus 3, this is greater than or equal to 0. X plus 3 and 2x minus 5, this will be greater than or equal to 0, and if we consider x, it will be equal to minus 3, and if we consider 2x minus 5, then x will be equal to 5 by 2. Then what do? Just consider a number line. So this is a number line. How can we mark minus 3? Minus 3, let us say here we mark minus 3, right? And 5 by 2, let us say 5 by 2 is here. Now what do is simply just to remember, simply mark like this. This is the first step, this is the second one, and this is the third one. Whatever this is infinity, plus infinity, this is minus infinity, right? This is plus infinity, this is minus infinity, and whatever the values that are after 5 by 2, this will be positive. All the values are positive because the condition here is x plus 3, the equation, the inequality is greater than or equal to 0. So this will be positive, and you can change the sign alternatively. This will be negative, and you can change the sign alternatively. If this is positive, this will be negative, and this will be again positive. Now how can we write the solution set here? The solution set of this inequality is, whenever you are trying to write the solution set, the most important thing which you must look is this condition, whether it's less than or equal to 0, whether it's greater than or equal to 0. The solution set depends on this condition. So the solution set for this inequality is x is equal to, it is greater than or equal to 0, which means we must consider the positive values, right? All the values which are greater than or equal to 0 are positive. So just consider positive values. What is the range of positive values? Minus infinity to minus 3, right? Minus infinity to minus 3. Union, this is negative range, so just ignore it. And what is the positive range again? 5 by 2 and plus infinity. Okay. So irrespective of this condition, whether it's greater than or equal to 0 or less than or equal to 0, the sign that you must put before infinity, right, whether it's minus infinity or plus infinity, must be a parenthesis bracket or the open bracket, right? It's a round bracket. Whereas if it is greater than or equal to 0, greater than symbol is there, so the minus 3 is also included. When a number is included, then we have to keep a squared bracket. So this is a round bracket, and 5 by 2, this is also included, so this is a square bracket. So the solution set of this quadratic inequality is minus infinity to minus 3 and 5 by 2 to plus infinity. Let us solve one more inequality, which is x into x minus 2 into x minus 5 into x plus 3, this is greater than 0. Now when this is greater than 0, we can say that x is equal to 0, x is equal to 2 in this case, right? And x is equal to 5 and x is equal to minus 3. Let us plot them. Take this number line, and if we plot 0 here, then 2 will be here, 5 will somewhere be here, and minus 3 is here. The same process. So this is greater than 0, and from the rightmost side, the values that are after 5, right? This will be positive, and alternatively we can change the sign. If this is positive, this will be negative, and this is positive, this is negative, and this is positive. This will be minus infinity, this will be plus infinity. So what is the solution set of this one? Solution set of this inequality is x is equal to, it is greater than 0. So we shall ignore the negative range, right? Negative values, we shall ignore the negative range and consider the positive range, which is minus infinity to minus 3 union, and this is negative, so this is positive, 0 comma 2 union 5 comma plus infinity. So here we do not have equal to symbol, right? Equal, it's just greater than 0. That's why we have marked with round brackets, right? I will just summarize the inequality here. So this is the summary of the quadratic inequalities. The first step you must follow is you must solve the expression, the quadratic expression, and find its roots, and then draw the number line and mark the reasons, right? So you will start with positive, positive, negative, positive. So alternatively you will change the signs, and the third step is to check the equation, then write the solution set of that equation by using the number line. And what are the rules you must follow? Just check the expression. If it is greater than or equal to 0, then take the positive sign and ignore the negative sign, negative region. The less than or greater than, right? Where equal to is not there. If equal to is not there, then you must use the open brackets, open interval brackets. If equal to is also there, like less than or equal to or greater than or equal to, then you must use closed interval brackets, right? Like this. And one more thing, for infinity it is always open interval brackets. If it is like this, like minus infinity comma 5, so you must use only open interval brackets. It shouldn't be like this, right? It shouldn't be like this. Let us solve the last question of the inequality, quadratic inequality. So solve for x for this inequality. The condition is greater than 0. Now you may say, can we take the denominator this side and we can equate x square minus 5x plus 6 is greater than 0? Can we do that? No, we cannot do that. Why can't we do that? We don't know whether this is positive or negative. If it is positive, we can do that. If it's negative, we cannot do that. So first let us find out whether this is positive, the denominator is positive or negative. If we multiply this, the numerator and denominator with the denominator, let's say x square minus 5x plus 6. So x into x plus 2 into 4x minus 1 by the denominator, which is x plus 2 into 4x minus 1. So this will be greater than 0, right? If we multiply, then it will be square, and as this is square, we can confidently say that the denominator is positive, because even if it's negative, the square will take care of that and it will become positive. Now we can bring this to the other side, right? So if we bring this to the other side, only the numerator will be remained. Now what will be the numerator? It will be x square minus 5x plus 6 into x plus 2 into 4x minus 1. This will be greater than 0. And if we solve this equation first, it will be x minus 2 into x minus 3 into x plus 2 into 4x minus 1. This will be greater than 0. So x is equal to 2 in the first case, 3 in the second case, minus 2 in the third case, and 1 by 4 plus 1 by 4 in the last case. Let us plot them on the line graph. So this is minus 2, 1 by 4 will be here, plus 2 will be here, and 3 will be here. So the extreme point, the extreme right hand side will be positive, this will be negative, this will be positive again, this will be negative, and this will be positive. As the condition is greater than 0, consider the positive values. So if we consider the positive values, it will be minus infinity to minus 2 union 1 by 4 comma 2, right, and 3 comma plus infinity. So as it is just greater than 0, we shouldn't use the squared brackets, so we shall use the round brackets. So minus 2, 2 and 3. So this is the solution set of the inequality. Let us move on to the sum and product of roots. If we consider a quadratic equation ax square plus bx plus c, which is equal to 0, where a is not equal to 0, the sum can be taken as minus b by a. Sum of the roots can be taken as minus b by a, right, which is minus b is the coefficient of x, a is the coefficient of x square, and product can be taken as c by a. C is constant and a is the coefficient of x square. Let us solve this question. Akash and Kiran noted down a quadratic equation from the blackboard. Akash made an error while noting down the coefficient of x and got the roots as 14 minus 2. Kiran made an error in noting the constant term and got the roots as minus 8 and 5. Find the greater of the two roots of the actual equation. So if the equation is ax square plus bx plus c, this will be equal to 0. While noting down the coefficient of x, if Akash makes an error, it won't affect the product of the roots. So what is the product of the roots? Alpha beta. Alpha beta is 14 and minus 2, which is minus 28. And what about alpha plus beta? Kiran made an error in noting down the constant term. So noting down the constant term, if he makes an error while noting down the constant term, it won't affect the sum of the roots. So minus 8 plus 5 is the sum of the roots, which is equal to minus 3. So minus 28 and minus 3. This is the product and this is the sum. And what are the roots? Alpha comma beta. We have to make sure that the product is minus 28. Right, alpha beta must be minus 28 and alpha plus beta must be minus 3. So alpha is minus 7 and beta is 4. Right, the condition is satisfied. And the question is, find the greater of the two roots. Which one is greater, minus 7 or 4? Obviously 4 is the correct answer. Now find the value of p if one root of the quadratic equation x square minus 12x minus p is twice the other. So one root is twice the other. So if one root is r, then the other one will be 2r, right, which is equal to 3r. So this sum is equal to 12. As we know, this is the sum of the roots. So 3r will be equal to 12 and r is equal to 4. R equals to 4. If r is equal to 4, one root will be 4 and the second root will be 8. So what about the product of two roots? Product is 8 into 4, which is 32. And we know product can be calculated as c by a. So c by a is 32. So c by a in this case is, c is minus p, right? So minus p, and a here is, which is coefficient of x square, is 1. So this is 32. So p will be equal to minus 32. So here, how did we calculate 3r is equal to 12? We know 3r is a combination of r plus 2r, which is the sum of the roots. Right, we know sum of the roots can be taken as minus b by a. Here minus b is minus of minus 12 and a is 1, right? So minus b by a is 12. So 12 is equal to 3r and the value of p is minus 32. Now discriminant and nature of roots of a quadratic equation. So mainly we have three conditions. Discriminant. So when discriminant is equal to 0, when discriminant is greater than 0, and when discriminant is less than 0. But what actually is discriminant? If we consider the quadratic equation formula, which is minus b plus or minus root of b square minus 4ac by 2a, this part, which is b square minus 4ac, this is the discriminant. And as this is a discriminant, we can also find the nature of the roots. As this is under the root, we can find the nature of the roots of the quadratic equation, any quadratic equation. Now, when this part is equal to 0, just imagine when this part is equal to 0, the value of the other part, which is minus b by 2a, this will be equal. So we have equal and real roots. We have equal roots and real roots. If discriminant is less than 0, what will happen? If discriminant is less than 0, then root of any negative value will be a complex number, right? So we have complex roots. We don't have real roots, we have complex roots. Now, the third case, discriminant is greater than 0. When discriminant is greater than 0, the first case is we have perfect square, right? When discriminant is equal to perfect square. And the second case is when discriminant is not equal to perfect square. So discriminant is equal to perfect square, and the second one is discriminant is not equal to perfect square. If it is perfect square, then it will be rational and will get unequal roots, and if it is not a perfect square, then it will be irrational and the roots unequal. So these three are the conditions of discriminants and the nature of the roots. If d is less than 0, discriminant is less than 0, then the nature of the roots is complex. If d is equal to 0, then the nature of the roots are equal and real. And if d is greater than 0, then we have two conditions. The first one is when discriminant is equal to perfect square, when discriminant is not equal to perfect square. If it is equal to perfect square, it will be rational and unequal. This is the nature of the root. And if it is not equal to perfect square, then it will be irrational and unequal. If we solve a few questions, then you will understand the concept better. And always remember one thing. And 2 points here to note is, if the coefficients are rational, irrational roots occur in pairs. What does this mean? This means, let's say for a quadratic equation, 3 plus root 4 is one of the roots, right? In a quadratic equation, there will be two roots maximum. So one of the roots is 3 plus root 4. If this is one of the roots, then you can confidently say that the other root is 3 minus root 4. But when the coefficients are rational, when the coefficients of the equation, let's say ax square plus bx plus c, when the coefficients of this quadratic equation are rational, then you can say that the other root is this. So it is conjugate. It is also known as the conjugate. The second point to note is, if the coefficients are real, complex roots occur in pairs. What does this mean? Let's say one of the roots is 3 plus 2i, right? I is imaginary. Then you can say that the other root is 3 minus 2i. But the condition is the coefficients must be real. If the coefficients are not rational, you cannot say that 3 plus root 4 is one more root for 3 minus root 4. Only if the coefficient is rational in the first case and the coefficient is irrational in the second case, then only you can apply this. Let's solve this. One of the roots of the quadratic equation x square minus px plus q is 0. One of the roots is 2 plus root 3, and here p is equal to q minus 2 minus 3 root 3. Find the greater of the two roots. So this is the quadratic equation. This is one of the roots, and this the value of p is also given. So what we shall do is we shall substitute this root in the place of x. So what do we get? 2 plus root 3 whole square minus p into 2 plus root 3, and instead of q we'll take this condition in order to substitute the value of q. So q will be equal to p plus 2 plus 3 root 3. So this will be p plus 2 plus 3 root 3. This will be equal to 0. If we further solve, so if we solve this, we will arrive at this equation, and let us rationalize this one. If you rationalize this, we will get p is equal to 9 plus 7 root 3 by 1 plus root 3 into 1 minus root 3 by 1 minus root 3. So this will be, so p is equal to 6 plus root 3. We know p is a combination of both the roots. So let us subtract this root here, minus 2 plus root 3. So this will get cancelled, and we are left with 4. So 4 is the other root, and the first root is 2 plus root 3. We are asked to find out the greater of these two roots. So between these two roots, 4 is the greater one, because 2 plus root 3 is somewhere around 3.7 or 3.7. So 4 is greater. So if the roots of 8 power m x square plus 8x plus 32 power m is equal to 0 are real and equal, find the value of m. If you remember the condition for real and equal, what is the condition? When determinant is equal to 0. When determinant is equal to 0, then only the roots will be equal and real. So d will be equal to 0. What is d? D is b square minus 4ac. This will be equal to 0. So what is b here? B is 8 square. B is the coefficient of x. So 8 square minus 4 into 8 power m. What is c? C is 32 power m. This will be equal to 0. If we further solve this, we will get, because we have to convert the bases, right? The base, each and every base with 2. So 2 power 3 whole square, this will be equal to 2 square into, so the bases are equal, so we can equate the exponents. So this will be 6 is equal to 2 plus 8m, and m is equal to 1 by 2. This is the value of m. So let us look into maxima and minima of a quadratic equation. If you remember the quadratic graph that we have discussed in the earlier slides, it will be a parabola, right? Let's say f of x is equal to ax square plus bx plus c. If the coefficient of x square is positive, then the parabola will be like this. If that is negative, then it will be inverse. The parabola will be like this. So if a is greater than 0, the parabola is like this, and if a is less than 0, the parabola is in this way. If a is less than 0, we will get maxima point here. This will be maxima. When a is greater than 0, we will get minima. And what is the maximum point here? When a is greater than 0, it will extend till infinite, right? Infinity, it extends till infinity. When a is less than 0, it extends till minus infinity. but we want maximum minimum point. So if a is greater than 0 we'll get minima, and if a is less than 0 we'll get maxima. And please remember this, the maxima or minima point, right? So the maxima or minima of a quadratic function will be obtained at the point x is equal to b minus 2a. We will apply this concept in various problems so that you will be conceptually very clear. So at this point we'll get maxima or minima. We can get both. If a is greater than 0 we'll get minima, if a is less than 0 we'll get maxima. At which point? At x is equal to minus b by 2a. So let us solve this. Find the minimum value of 2x square minus 4x plus 3. So if you observe a is greater than 0, right? So the parabola will be like this, and we will get minima, not maxima, right? We will get minima. So at what point we will get minima? We will get minima at x is equal to minus b by 2a. And here what is b? B is the coefficient of x. So b is minus 4, minus of minus 4, and 2 is the coefficient of a. So 2 into 2, this will be equal to 1. At x is equal to 1 we will get the minimum value. But what is the minimum value? Just substitute x in this equation. To get x, we substituted the coefficients in minus b by 2a. That's why we'll get minima at this point. After getting the value, we have to substitute in the equation, in the quadratic function, to get the value. To get the point, we use this. To get the value, we directly substitute here, right? So 2 into 1 square minus 4 into 1 plus 3, this will be equal to 1. So what is the least value? What is the minimum value? Minimum value is 1, is also 1. Let's move on to the next question. Would the expression 18x minus 3x square plus 8 has a maxima or a minima? This is the first one. The second question is, for what value of x would the maxima or minima occur? And the third one is, and what is the maxima or minimum value? So if we observe, we will rewrite the expression given. What is the expression? Minus 3x square plus 18x plus 8. This is the expression. So if we observe the coefficient of x square, that is a is negative, a is less than 0. So what is the shape of the graph? It is a parabola inverted, and when it is inverted we will get maxima, right? And we know at x is equal to minus b by 2a, we'll get the point, right? And if you substitute the value of x, that point in this equation, we will get the value, right? So the first one is ruled out. We will get maxima and not the minima. Let's move on to the second one. For what value of x? So let's calculate x. X is equal to minus b. What is minus b? Minus 18 by 2 into a is minus 3. So this will be equal to 3. X is equal to 3. So x is equal to 3. Second question has been answered. And the final one, what is the maximum or minimum value? So here we will get maximum value. So we'll get maximum value, and what is the value? Let's substitute x is equal to 3 in this equation, in this expression. So 3 minus 3 into 3 square plus 18 into 3 plus 8. So this will be equal to 35. So 35 is the maximum value. So like this we will solve the maxima and minima problems in maxima and minima in quadratic equations. Now what is the condition of any two quadratic equations in which there will be one common root? Is there any condition that must be satisfied? Yes, there is a condition. I will just derive the condition so that, anyway, derivation is not necessary. You no need to remember the derivation. But before before projecting you the formula, I will just derive the equation. So if we consider a quadratic equation, let's say a1x square plus b1x plus c1 is equal to 0. And one more equation, a2y square plus b2y plus c2 is equal to 0. Let us say the common root is alpha. Now if we multiply this the first equation with a2 and the second equation with a1, we'll get, so we will arrive at these two equations when we multiply a2 and a1 with these quadratic expressions. Since we have assumed the the common root for these two expressions as alpha, let's substitute this with alpha, substitute x with alpha. So after substitution we get a2a1 alpha square plus a2b1 alpha plus a2c1 is equal to 0, and a1 a2 alpha square minus a1 b2 alpha plus a1 c2 is equal to 0. So these two can be cancelled, and if we further simplify these two equations, we will get alpha by a2c1 minus a1c2 is equal to 1 by a1b2 minus a2b1, right, after further simplification. Now we will do one thing, we will multiply the first equation, the first expression with b2 and the second one with b1. Now what do we get? So we will arrive at these two equations, and if we further simplify, we will arrive at a similar condition like this, which is this condition, right? Now we can equate, because see the RHS part is equal, right? So we can further generalize this equation as this condition as, so alpha squared by b1 c2 minus b2 c1 is equal to, so we can generalize these two equations as this one. But this equation, to remember this equation seems much complicated, so we will further simplify this equation now. So if we simplify this, we will get alpha square as this and alpha as this, and if we substitute alpha here, then we will get, so we will arrive at this equation. And if we further simplify, so if we further simplify, we will arrive at this condition. This is the condition for one common root. This is the condition for one common root, which means if we have two quadratic expressions, right, two quadratic equations, so only the quadratic equations has roots, quadratic expressions do not have roots. So if we consider two quadratic equations, if the two roots, we have two roots for one equation and two roots for another equation, among those four roots, if any two roots are equal, if one root from one equation and one more root from another equation, if two roots are equal, then it must satisfy this condition, right? If that satisfies, if the two roots satisfy this condition, then the two equations have one common root. So you can remember this, but I will tell you how to remember this. So we have a1 here, a2 here, right, b1, b2, c1, c2. Let me write c1, c2 one more time, right? We'll go in this order, c1, a2, right, c1, a2 minus a1, c2 whole square is equal to, now this order, a1, b2 minus b1, a2, a1, b2 minus b1, a2 into b1, c2 minus c1, b2. So c1, a2 minus a1, so it can be c1, a1, c2 minus c1, a2, because anyway we are squaring this, even it's negative, it will be positive at the end. So c1, a2 minus a1, c2 whole square is equal to a1, b2 minus b1, a2 into b1, c2 minus c1, b2. So you can remember this one by using this. Just frame this a1, a2, b1, b2, c1, c2 and again c1, c2 on the extreme left hand side. You can remember easily. Let us apply this condition. So for which of the following values of q the two equations have a common root? So these two are the equations. So we shall apply the condition that we have just learned. So we shall take the coefficients 3, 6, minus 2, minus 17, q 12, again q 12. So 6 into q, 6q minus 12 into 3, 36 whole square. This is equal to 3 into minus 17 minus of 6 into minus 2. This will be minus 51 plus 12 into minus 2 into 12. This will be minus 24 and this will be minus of minus 17 into q. This will be plus 17q. So we'll have two values. Q is equal to minus 8 by 3 and one more is q is equal to minus 15 by 4. But our question is, for which of the following values of q the two equations have a common root? So minus 8 by 3 is there, so option B is the answer. This appeared in ZAT. Now is there any condition for two common roots? We learned condition for one common root. The condition for two common roots is even simpler. So if we take two equations, right, two quadratic equations, sum of the roots must be equal, right? Sum of the roots must be equal and the product of the roots must also be equal. This is the only condition for the two common roots. So what is the sum in the first case? Minus b by a, right? So minus b1 by a1 and second case minus b2 by a2. And what is the product? In the first case it is c1 by a1 and product in the second case is c2 by a2. So if we take a1 and a2, if we bring the coefficients of x square on one side, we will get a1 by a2 will be equal to b1 by b2, and if we take the coefficients of x square on one side, in the product case as 1 by a2, this will be equal to c1 by c2. This is the only condition. So which means we can say that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. This is the condition for two common roots. If both the roots of both quadratic equations must be equal, then they must satisfy this condition. If they satisfy this condition, then the two roots are common for both the quadratic equations. Now, relation between coefficients and roots. So if you want the derivation, I will make a separate video to know the derivation, or you can find somewhere, you can find the derivation. I will directly write the relation between coefficients and roots. So if we take for cubic equation, we shall first look into the relation. If we take a cubic equation as ax cube plus bx square plus cx plus d is equal to 0. So ax cube, so since it is a cubic equation, it has 3 roots, not 2 roots. So 3 roots, let the roots be p, q and r. Now we shall obtain the relation between these roots and the coefficients, right? If we add these roots p plus q plus r, this will be equal to minus b by a, and the product of two roots, right, pq plus qr plus pr, the product of this will be equal to c by a, right? So here we are considering plus, minus. Here I guess in the second case we are considering plus, and third case we have to consider minus, just for remembering in a simple manner. So the product of all three is pqr, this will be equal to minus d by a. So here minus plus minus, okay. So this is the relation between the coefficients and roots for cubic equations. For any higher order equation, what shall we do is, let's say take any higher order equation, let's say higher order equation of degree 5. So this will be ax power 5 plus bx power 4 plus cx cube plus some dx square plus ex plus f is equal to 0, right? If this is a higher order equation of degree 5, of order 5. So let us as this is of order 5, it will have 5 roots. Let us name the roots as r1, r2, r3, r4 and r5. Clear? Now we shall obtain relation now. So r1 plus r2 plus r3 plus r4 plus r5, this will be equal to minus b by a as usual. In the second case, we will obtain the product of two roots. Two roots. So r1 r2 plus r1 r3 plus so on till r4 r5. So how many roots will get the terms? How many terms we will get? 5c2 terms, that is 10. So this will be equal to, we considered minus in first case, so plus in second case, c by a, right? Now we will consider three roots, three roots, r1 r2 r3 plus r1 r2 r4 so on till so on. And how many terms we will get here? We will get 5c3 terms, and here so 5c3 is 10. So this will be equal to minus d by a, and this is second case. And the fourth case is product of 4 roots, r1 r2 r3 r4 plus r1 r2 r3 r5 so on. This will be plus e by a, and how many terms we will get? We will get 5c4 terms, which is equal to 5 terms. And the last case is product of all these roots, that is r1 r2 into r3 r4 into r5. This will be, here we have taken plus previously, so we will take minus of f of a. You can apply this rule to any order. Here we have taken order 5, you can apply this to any order. The rule remains same. The sign changes alternatively. First we have to take the positive values, and then first we have to take the sum of all the roots, and then you have to take the pairs, the multiplication, the product of the roots. First 2 first next 3 next 4 according till the order. It's a very simple concept. And let us move on to the Descartes rule of signs. So from the René Descartes rule of signs, we can understand that it gives an upper bound on the number of positive or negative real roots of a polynomial with real coefficients. You will understand what upper bound is as we move forward. So let us say, let's take a polynomial. Let's say f of x is equal to 5x power 6 minus 3x power 4 plus 7x minus 5. So let's take this. What does this rule tell us is, if we want to implement this, then what we must do is this, the powers, we must have all the powers. But here, do we have all the powers? We have 6, but 5 is not there. We have 4, again 3 is not there, again 2 is not there. We have 1 again. So we will apply all the powers here. We will insert all the powers. 5x power 6 plus x power 5 is not there, so we will simply put 0 into x power 5 minus 3x power 4 plus 0x cube plus 0x square plus 7x minus 5, right? So in order to find the positive real roots, right, in order to find the positive real roots, we'll take the coefficients. What are the coefficients? The coefficients are 5, right, plus 0, minus 3, plus 0, plus 0, plus 7, minus 5. Signs are really important because this rule is all about signs, right? So please be very careful while noting down the signs. So how can we apply this rule is we have to just observe the signs. How many signs are changing? How many times they are changing? So plus 5 no change, plus 0 and minus 3 this is one change. From minus to plus this is one change. From plus to plus no change, plus to plus no change, plus to minus this is one change, right? So 3, 1, 2 and 3. So positive real roots are 3 or 3 minus 2, which is 1. So why we subtracted 2 from 3 is because in this rule we will subtract 2, we will constantly subtract 2, right? We don't take any other constant, we'll just take 2 and subtract this. So this is the positive real roots. The positive real roots for this equation, for this polynomial can be 3 or 1. But what about the negative roots? Negative real roots. What about the negative real roots? Here what we did is we just substituted f of 1 here, right? We substituted f of 1. For negative real roots we have to substitute f of minus 1 in the place of x. In the place of x we have to substitute minus 1. So minus 1, if you substitute 5 into minus 1 power 6, as this is even, the sign won't be changed. So 5 again plus 0 minus 3 plus 0 minus 7 and minus 5. How many signs are changing? How many times they are changing? Plus no change. Plus, from plus to minus there is one change. Minus to plus there is one more change, and from plus to minus there is one more change. Minus to minus no change. So 3 times. So the negative roots, real roots can be 3 or 3 minus 2, which is 1. Alright, very simple concept. Let us apply this in a question, in a problem, so that you will be much more clear. So the question is, the number of real roots for the given polynomial can be. So the polynomial is given. If we observe, the first step here to observe is we have to have all the powers in the decreasing order: 5, 4, 3, 2, 1. So all are there, so no worries. So in order to find the real roots can be positive, it can also be negative. So first we shall find out the positive real roots. To find the positive real roots we have to just substitute 1. So f of 1 is 1 power 5 minus 1. So 1 power 5 is 1. So 1 minus 1 plus 3 plus 9 minus 1 plus 5. So how many times the sign changes? Plus to minus one time, minus to plus one more time, plus to plus no change, plus to minus one change, minus to plus one change. So 4 times it's changing. So the positive real roots can be either 4 or 4 minus 2, which is 2, or 2 minus 2, which is 0. I told you, right? Every time we will subtract the highest number with 2, and then we further subtract if it is being subtracted, right? And we shall move on to the negative real roots. For which we will substitute minus 1. So f of minus 1 is equal to minus 1, minus 3, plus 9, plus 1 and plus 5. Just substitute in this equation, you will get this. So how many times the sign is changing? Minus to minus no change, minus to minus no change, minus to plus one change, and there is no further change. So only one change, so the negative real root is only 1. But our question is the number of real roots for the given polynomial. Number of real roots. So in the first case the positive real roots are 4, it can be 2, it can be 0, but in the negative real roots it is only 1. So it can be 4 plus 1 or 2 plus 1 or 0 plus 1. So it can be 4 plus 1, which is equal to 5. It can also be 2 plus 1, this is equal to 3, and it can also be 0 plus 1, which is equal to 1. So these are the real roots, number of real roots which are possible for this polynomial. So this is all about the quadratic equations. and this is the part 2 of algebra. We will look into inequalities, modulus, and the remaining algebra part in the upcoming videos. See, we are not making each and every video into different parts, because at one go you can watch the complete master class, so that you won't miss any concept. And after this, you have to practice, you have to definitely practice, you have to revise all the concepts which are explained in this video. And also you have to practice the different questions. In the advanced sessions, of course, we will practice, we will delve into the moderate, we will delve into difficult, we will delve into easy level problems. So don't panic. And if you haven't subscribed our channel, do subscribe it. And I have provided the link, the Telegram group joining link in the description below, so you can also join our Telegram group. So thank you and all the very best.